Hi, my name is Olivier THERRIEN. I'll present my master's thesis on SSS3D, the fast neural architecture search for efficient three-dimensional semantic segmentation. This project was also sponsored by Synopsys. So SSS3D focuses on the problem of 3D semantic scene segmentation and the fact that individual training of networks is time-consuming for deployment on different kind of platforms. Also the fact that these networks often use complex operations that are not easy to deploy on most platforms, so it limits the number of platforms they can be deployed on, and that they're often over-parameterized and require multiple memory, a huge number of memory accesses. So SSS3D provides a multi-objective NAS framework that is fast, by using weight sharing, an early stopping during evaluation, and a two-stage search method. It also uses a point-based 3D semantic segmentation network called RandLA-Net as its supernet. So it's a network that already exists, so we can take the weights and apply them during weight sharing to make our search faster. And it also searches a design space that has more of 10 to the 17 designs to find computationally efficient variations of the network. So the search algorithm of SSS3D is based on genetic algorithms also. So it starts by sampling an initial population of subnetworks, random subnetworks from the search space. Plus, we also add the original supernet in the initial population to drive the search at the beginning to get good results from the start. And then we go to model evaluation and selection of the next generation's population. And this cycle goes on for a fixed number of generations. And then the Pareto optimal designs of the last generations are fine-tuned to improve the accuracy. So the RandLA-Net is our supernet. It has an encoder-decoder structure. It is based on one-by-one convolutions. It also uses random sampling to reduce the number of points from the point clouds at every step of the encoder. But to counter the information loss risk associated with random sampling, it uses a block that's called local feature aggregation that uses the KNN algorithm to gather the information from neighboring points before they're sampled. And our search space is based on the architecture of RandLA-Net. And it has two types of parameters. There are architectural parameters and sampling parameters. Architectural parameters are parameters that change the internal structure of the network, like the number of convolutional filters. And the sampling parameters, they do not change the internal structure. They just change how the network operates. So the stride of the one-by-one convolutions, the k-value of the KNN algorithm, and the subsampling ratio that determines the number of points that are used in the next stage. So the single stage search is the basic search mode of SSS3D. It searches over the complete search space for 60 generations. It optimizes the mean IOU error and a computational cost matrix, either the number of parameters or the number of flops. So as we can see, it finds interesting networks that present good trade-offs between accuracy and parameters and satisfy different kind of constraints without having to retrain every time. And also it shows that the networks were in fact over-parameterized often. But what SSS3D brings, what makes SSS3D fast is weight sharing and early stopping is its two-stage search mode, which splits the search into two search. So the first search is focusing on the sampling search space. So it searches only the sampling parameters for minimizing the mean IOU error and the number of flops for 20 generations. And then it takes the sampling parameters of selected network from the final Pareto optimal curve of the first search and fixes these sampling parameters to the architectures that are going to be searched in the second stage. So, and in the second stage, it's only the architectural parameters that are searched for a reduction of parameters and mean IOU error. And what it does compared to the single stage search is that it reduces search time. Because we need less generations to explore, to find good results, but we don't reduce the search space as the two types of parameters are searched. And also it finds networks that are optimized for both flops and parameters. SSS3D reduces search time by more than 99% for only single stage search by using weight sharing and early stopping, and two-stage search is 47% faster than the single stage search. And these are some of the networks found by SSS3D. So the SAP1 was found during the single stage search and increases the mean IOU by 0.27% while reducing parameters and flops. And SAP2 has the lowest parameters that we found by reduction of 52% for 61.5% mean IOU. And finally, AFP3 was found with the two-stage search and was discovered in only 1.4 GPU days and has the lowest flops with a 62% reduction. And yeah, thank you.